this video, we'll talk about convex hull. Convex hull is a line which envelopes all of the points in a plane such that there are no concavities in the shape. So concave is a shape which basically caves in like this figure, and convex is a shape which does not have any of these concavities. So it's nothing but a line which covers all the points. So essentially it's also called the gift wrapping algorithm. So you're having a gift and you're wrapping it. So you could also consider a board with nails coming out of it. And if you stretch a rubber band around it, the shape you'll get is the convex hull. So it's just a set of points which cover your given 2D plane. So in this video, we'll be using Pygame to plot some points and draw the convex hull around those points. So there are multiple ways of doing that, and in this video, we'll look at the Jarvis March algorithm. So let's first look at the output. So this will be the output. So you can see the point. So this is a 2D plane, and the blue line you see out here is the hull. So the algorithm for this is quite simple. So we first select the leftmost point. So in this case, this would be the leftmost point. And once you have done that, we will select all the points in the hull by repeatedly selecting the point which has the maximum anti-clockwise angle. So with respect to this point will have the maximum anti-clockwise angle. So it is the most anti-clockwise point as compared to this point. So that will be the next point in the hull. The reason for selecting the leftmost point is that it will most certainly be there in our hull as it is one of the extremes. So for this we'll use a brute force approach, and we'll be checking every point. So we first select a point which will definitely be there in the hull, and then we check all the points for the next point which will be there in the hull. Okay, so essentially we will be checking each and every point multiple times. So the time complexity of this algorithm will come out to be n times h, where h is the number of points in the hull. So we'll look at that later. So first of all, let's start looking at the algorithm. So we have to select the point which is the most counterclockwise to our current selected point. So how do we do that? So the easiest way of doing that is by the cross product. So as you may know, the cross product of two vectors is a vector which is mutually perpendicular to both of those vectors. So if you consider this figure, so this is the current point, next point, and the checkpoint. So there will be two vectors, one which is found by next point minus current point, and one which is found by checkpoint minus current point. Okay, so if we take the cross product of these two vectors, we'll be getting a vector which is perpendicular to both of those vectors. So that vector will be either pointing out of the plane or pointing inverse the plane, or pointing into the plane. Okay, so we can use that to check if the point which you're selecting is to the clockwise direction or to the anti-clockwise direction. So consider in this case, so the checkpoint is towards the anti-clockwise direction as compared to the next point. So if we take the cross product, so it will be a vector which is coming out of the plane, right? If you remember the right hand thumb rule, so you keep your palm at a current point and next point and curl your fingers towards the checkpoint. So that vector is coming out of the plane. So that means that it is towards the anti-clockwise direction. And if it was the opposite case, if this point was the checkpoint, it would have been towards the clockwise and the vector would have pointed into the plane. Okay, so that is the basic funda behind how we'll get this convex hull. So it is just like finding the greatest element in the array. So what you'll do in that case, you'll fix some point and you'll check all the points with respect to that point if they're greater than that point. If they're greater, you'll replace the point with the point which is greater, and you will iteratively continue this process until you find the largest point. So out here also we do the same thing. We fix a random point. So in this case we have fixed next point, which is a random point, and we are checking all the points by the variable checkpoint, and we are checking if they are anti-clockwise or counter or clockwise. And if they are anti-clockwise, we'll update next point as checkpoint, and we'll keep on doing this process until we get the point which is furthest to the anti-clockwise direction. So I hope that is clear. So we'll look at the code now, and let's first look at a visualization to make you feel better about this. So I'll close this output and okay. So as you can see, this is the algorithm we are following. So for one hull, it is making so many calculations, you can see. Okay, so this is how the algorithm would look. You don't need to draw the internal lines. I've just added them for to make it look better and also to help you visualize it better. Okay, so this will be our hull, and the internal lines which you see are the comparisons it made. Okay, so let's dive into the code. So the first step would be Pygame initialization. So as we have done in the previous snake video, we'll be initializing Pygame in a similar way. So there's nothing fancy about this. So we'll import Pygame, we'll import numpy, and then pygame.init to initialize Pygame. We'll set the window by this command, and we'll set the clock. So we'll be setting the clock to basically control the speed of our output. And then we are setting the caption, which is convex hull, and this is the main loop which keeps it running till we press the quit button. So if event.type is quit, we quit the Pygame window. So if I run this, then it will be just a plain window. So it's open here. Yeah, so it will be a plain pure black window. Okay, so let's add some code into this. So the first step would be to add the points, right? So let's have the points here. So let's make it for 10 points. So n equals to 10, and then we'll assign some random values to these coordinates. So let's say I'll have points is equal to numpy dot random dot randint. So I want my plane to consist of these points, but I don't want them touching the edges. So I'll keep some buffer and assign them between 25 and 475. Okay, so this will give me some points with a little buffer. So I'll have this as an array. So the size of that array or list would be 2n. Okay, because I want, so for n points, I want 10 coordinates. So 20 x plus y coordinates. Okay. Okay, so I'll have two variables now. So these are the points which I'm getting. So I have to make them into chords. So these will be the coordinates. So I'll combine two of them to make a coordinate. And the next will be the hull. So this will be the set of coordinates in our hull. Okay, so these two lists we have to populate in using our code. So first we'll populate the chords array, which is the coordinates. So for I in range, so I'll take length of points -1, and I'll iterate it by a difference of 2 because I want 2 points for each coordinate. Okay, so so let's draw the circle. So that will be pygame dot draw dot circle. So these will be the circles for the individual points on the window. So this is our window, our plane. I've defined it here. Okay, and so let's have a variable called point color. So this will be the color of our points. We'll specify it above. And so for the coordinates, I'll have points of I and points of I plus 1. Okay, so so every two consecutive points will be assigned like this. So for the size, I'll specify 4. So this will be the this will specify the radius of the circle. And so let's populate this chords array. So chords dot append, and we'll append this point out here to this array, and let me specify the square brackets. Okay, so I guess that will do, and I'll add a display update to help you to display the contents which we've added. Okay, so I guess this should work out, and we haven't specified the points color, so I'm gonna fetch some values into that. So for the color, so let's specify some colors out here. So this will be the point color, hull color, and line color. So these are the three colors we'll need. Okay, so I guess this should do. So we got an error. So the name point is not defined, so I guess it was points. And yep. So as you can see, these are the points which we got, and we'll build our hull around these points. Okay, so so let's continue with the code. So we have made the points, and in order to make the hull, So what we need to do the first is have our leftmost point. So as we discussed in the algorithm earlier, the leftmost point will always be there in the hull. So in order to find the leftmost point, I'll have a variable called leftmost x. So I'm basically sorting the list, and the leftmost point will have the least x coordinate. So that is the logic. So leftmost x is minimum of x coord of 0, let's say. Oops. For x coord in chords. So x coord in chords is iterating the array, and I'm finding x coord 0, which will be the minimum. Okay, so this is the minimum x coordinate. Now we have to find the entire coordinate corresponding to this coordinate. So that will be my leftmost point is equal to t for t in chords if leftmost x is equal to t0, I guess. Yeah, so this will be so I have to make my leftmost of x equal to the x coordinate of that point which I'm selecting. Okay, so this is the x coordinate of that point. I'm finding the point corresponding to this x coordinate. So I'm checking if the x coordinate which I found was equal to the x coordinate of any other point. So this will give me the leftmost point. I'm taking the 0th index out here because so that will be a 2D array, and I have to make it into a 1D array. So that is why I'm putting this 0 out here. And so let's draw the circle to denote this leftmost point. So I'll have pygame.draw.circle on the win, and I'll have hull color here, and I'll have the leftmost point, and let's say 4 as the thickness, and pygame dot display dot update. Okay, so I guess this should work. So let's check it out. Okay. Square bracket here. Okay, so there were a couple of typos out there, but now as you can see, I'm getting the leftmost point. So let me run this again. Yeah, so this is the leftmost point which I've got. And so once you have got the leftmost point, we can proceed to getting the other points. So my leftmost point is the first point in the hull, right? So I'm defining a variable called current point, and I'm setting it as the leftmost point. So now this current point will be added to my hull, and based on this current point, I'll get the remaining points of the hull. Okay, so yeah, let's add the next points. So for adding the next points, what we'll have is we'll have to have a loop in which we are iterating through all the points. So first of all, I'll have a random point which will be my next point. So I have to think of a logic to generate that next point, and then I have to create checkpoints which will basically be compared against each of those next points to find the point which is most towards the anti-clockwise direction. Okay, I hope that makes sense. I'm not sure if I'm being clear, but I hope that makes sense. So I'll have a for infinite loop here. We can break out of this loop when required. Okay, so this is the main part of the code. So we'll have three variables out here. So you need to pay attention to what these three variables are. So first is the current point, which we've already defined. So this will be the point in the hull. The next point is a random point to serve as a reference. And the checkpoint is basically all the points in the array, and they are to be checked against the next point. And if the checkpoint is more towards the clockwise direction, we will replace the next point by the checkpoint. And after each iteration, the final checkpoint which we get will be the current point. Okay, so with that, let's go to our loop. So we'll have an infinite loop, and in that loop, what we first need to do is we need to append the current point which we found above to the hull. So our hull now has the current point. Okay. Second, we need to define the next point. So this should be a random point and it should not overlap with the current point, otherwise we'll get a 0. So I'll assign uh, any random point in the array which is not the current point. So I'll take the current points index and add 1 to that. Okay, so in that case it will be random as well and it will not be the same as the current point. So I'll have chords dot index of current point, okay, and +1. Okay, and since it may exceed the limits, I'll do a modulus n to ensure that we always get a legal value. Okay, so for checkpoint in chords, so this is the array which consists of all, so this is the loop, sorry, so this is the loop which consists of all the checkpoints which are to be checked against the next point. So if now we have to check the direction, so let's have a direction function. So if direction, and so what will be the parameters in this? So I'll pass the 3 parameters: current point, next point, and checkpoint. Okay, so these are the 3 parameters. So if this happens, so I'll return some value in this. If that value is true, that means the point is anti-clockwise. So I'll have the updation. So next point will become the checkpoint. Okay, so this will continue till I've exhausted the list of points in the list. Okay, and then I have to draw a line to connect the selected point and the previously selected point, because I have to draw the hull, right? So I've already appended one value to the hull, and I'll be getting the second value of the hull right here. Okay, so I have to create a line between this current point and this next point. Okay, I hope that's clear. So I'll have pygame.draw.line, pygame.draw.line. So I'm drawing the line out here on the window between, with the line color which I've defined earlier, between the current point, which is the first point of the hull, and the next point, which is the second point of the hull. And let's say the thickness is 4, and we are updating the display. Okay, and once we've done that, in the end we'll update the current point as it needs to point to the updated hull value, updated hull's next point. So current point will be equal to next point. Yeah, so I guess this should work. And we haven't defined the direction function, so let's define that. So let me define direction. Yeah, so this is sort of an important part. Okay, so if you have two vectors v1 and v2, so the cross product of those two vectors would be the x coordinate of v1 into the y coordinate of v2 minus the y coordinate of v1 minus, sorry, into the x coordinate of v2. Okay, so this will be the cross product if I had only two components each, the x coordinate and the y coordinate for both the vectors. If you had multiple coordinates, you'll have to use the determinant to determine the formula for the cross product. So we have to use this similar formula for a, b, and c. Since my vectors are differences between the coordinates, so I'll have b minus a cross c minus a. So this will be the cross product. So as you can see, these are the two differences between the vectors, so don't get confused by this formula. It's just the same as this. Okay, and it's the x coordinate of the first times the y coordinate of the second minus the y coordinate of the first times x coordinate of the second, and I'm checking if this value is lesser than 0. Now you might be confused here. because in cross product, a value which is coming towards you or out of the plane, which indicates that the second vector is towards the anti-clockwise direction, so that vector has to be positive. But out here I'm using negative. So why is that? This is because Python does not follow the exact same convention as the Cartesian coordinates, which we know. So so if the Cartesian coordinates were like this, Python representation of that would be a flipped image of it, because in Python, in the Pygame window, the origin is towards the top left corner of the screen, and as you move away from that origin, the value of x coordinate and y coordinate would increase. So if I were to move down in my Pygame window, my y coordinate is increasing, whereas that would have been the opposite in case of regular Cartesian coordinates. So that is why I'm taking the values which are lesser than 0. So I'm checking if it's lesser than 0, then I'm returning a true value. So I think this is done, and we need to add a check out here. So as you can see, there is no escape condition from this infinite loop. So when will we terminate the loop? So the answer to that is when our hull is complete. And when will the hull be complete is when we'll go full circle and we'll arrive at the starting point. Okay, so if my um, current point, which will be the point of the hull, which is as found by this algorithm, if it's equal to hull 0, which was the first point which we stored, in that case we have to break out of the loop. And current um, yeah, so this was the output generated by this code, and let me run it again. Yeah, so we got this hull out here. So as you can see, there are 10 points and 5 of them are used in the boundary, 3 of them are inside. So let's have some more points now. So let's say n is equal to 40. So I have 40 points out here, and this is the hull of that. So as you can see, it's giving the perfect answer, and all the points which are supposed to be inside the hull are inside it, and we have the boundary. So that sums up the main logic for this code. So a couple of things are left. So if you want to visualize it better, so what you can do is you can display each of those checkpoints which we have added. So out here, um, if we can copy this line and if we can paste it out here between the current point and the checkpoint. Okay, so actually we are checking with respect to next point and current point both, but next point will get a bit messy, so that is why I'm showing just the current point and the checkpoint. So these are the vectors out there, and it has to be checkpoint. And let's have a different line color. Yeah, so actually this was supposed to be hull color because this is the point of the hull and this is line color. Okay, cool. So first time you might, yeah, so it gets a bit messy, so I'll change this width to 1. And one thing I forgot to mention is the clock. Since we're focusing on the final output only, we don't as such require clock in this. But if we want to show the steps of how the hull is being formed, then I can add a clock out here. So I'll add clock dot tick and let's say 20. Yeah, so this should give a visual representation of the hull being formed. Yeah, so um, it's giving in batches. So if I keep that inside the loop, I guess I'll get it one by one. So let's close this. So since I'm not updating it here, I was getting the batch updates. So if I just do pygame.display.update, pygame.display.update out here, so it will update for each of the iteration. And yeah, so we got the code in which You can see how the hull is operating, and for every point it is checking all the other points and it is generating the hull out of it. So it's a very beautiful output, and I should not have done that. But okay, so you got the hang of it, and I think it'll start responding once it's fully constructed. Yes, it'll. So yeah, so so that's it for the video, I guess. So we have completed the convex hull out here, and yeah, so this is one more interesting application of Pygame. You need not always construct a game in Pygame. You can also use it for other visual stuff. So that's something you can use Pygame for. So I hope you liked this video. If you liked the video, please do subscribe, as there is ton of amazing stuff coming up. And thanks for watching.